Hi, I'm Rich with insideHPC. We're here at the GPU Technology Conference in San Jose, California, and I'm here with Steve Oberlin. Now, Steve, you're with Nvidia nowadays. What is your title?
I'm the Chief Technical Officer for Accelerated Computing, the Tesla business unit.
Okay, so you've been there a couple of months now? And
coming up on my 120-day anniversary.
120, okay. So I wanted to ask you about your role. I mean, you were the architect behind the famous T3E, the first really successful MPP system. What were the lessons from that machine that you're going to carry you forward in this role?
Well, I spent the last decade in enterprise computing and cloud computing, and one lesson I learned coming back is if you look away for a few years, Moore's Law is truly amazing. It's shocking. You remember that the T3D had a peak performance of 1 teraflops, and the T3E was the first supercomputer to sustain a teraflops on a real application. And today, a single Kepler GPU not only has a greater peak than the T3D, but also is routinely sustaining a double precision teraflops on various applications. Another lesson I learned is that some things are constant, like architectural balance.
Yep. And
the announcements that we made at GTC this year around Pascal with the memory bandwidth and NVLink are the kinds of architectural and technology advances that are needed in order to keep a balanced architecture between computation, communication, memory, bandwidth, etc.
Yeah. Well, let's double click on that because, you know, in HPC we have what they call the memory wall, right? And it seems like a problem that's not going away, but what's Nvidia doing towards that end?
Well, memory bandwidth is the limiter for a lot of applications. Anyone with HPC problems knows that. And in my experience, memory bandwidth has always been a packaging problem, but nowadays it's not only a packaging problem, it's also a power problem because we're completely power limited by what we can have in the envelope of packaging that we're allowed. And the announcements around the stacked memory for Pascal are a major step forward in that dimension by bringing the DRAM, by stacking it up and bringing it on the same substrate as the GPU. We're not only able to make the interface extremely wide, thousands of bits wide instead of hundreds of bits, but by bringing it so close, we're able to drop the power per bit that we move, and that lets us move a multiple of bandwidth per second for the same power.
Yeah. And what about NVLink going to that end? How does that come in?
That's in the exact same vein. Again, it's a power issue and a packaging issue. By bringing a high-speed signaling on chip and having it be only a third of the power per bit moved as PCIe, we're able to essentially offer 5 or more times bandwidth and still stay within that same power envelope.
Yeah. Well, I wanted to ask you, because one of the tweets I read this week is, where's Denver? And it wasn't mentioned in the keynote. It was announced last year, right? So could you remind us, what is Project Denver and where's it at today?
Well, I'm pretty sure we're not making any announcements around Denver, but obviously ARM is really important to us. You can see a big ARM presence in our mobile processors, and with the K1 at this GTC, there's just a ton of excitement around mobile applications in the embedded world for computer vision, for robotics, for mobile in vehicles, automotive. So it's really exciting, but I don't really have anything to say about Denver.
Okay, so it seemed like this was the year for GTC to start talking about machine learning, something I didn't remember hearing last year.
Right.
Well, how did GPUs fit into that world? And don't you have some experience with that in more recent?
Right. Part of what I was looking at over the past decade was infrastructure optimization for cloud computing, and a big part of that was trying to have the systems learn from experience and know when to anticipate spikes and recognize when there were going to be, anomalies that need to be responded to. And one of the things that's really been exciting about coming to Nvidia, and especially at the conference this year, is that GPUs happen to just be awesome at machine learning. A lot of machine learning researchers are here. There's a ton of papers. The technical sessions are really great, and they're now showing that almost all machine learning using deep neural networks and a variety of other applications and big data analytics are using machine learning to get order of magnitude speed ups on training for these very large and difficult recognition and classification recommender kinds of projects. So I'm really personally very excited.
Yeah. I mean, is this Nvidia's way to get into the enterprise? Do you think is this a
well? It's one way, I think.
Yeah.
It's one way certainly for us to broaden the market for GPUs. Another way I think that we're going to slip into enterprise is through our relationship with IBM. We announced at Supercomputing that we have a partnership that we've joined the Power Consortium, and anyone who's architecting a supercomputer these days knows that not only is the throughput processing really important, that gets done in parallel, and obviously NVIDIA GPUs are optimized for that, but oftentimes there's this pesky Amdahl's law scalar fraction that kind of refuses to be compressed out, and having a processor like the IBM Power series that just happen to be the world's fastest scalar processors, tightly coupled using a very high bandwidth link, is a pretty good picture.
Yeah. So with all these diverse architectures, last time I counted, there's like 13 you can buy today for HPC or something like that. What keeps you up at night about where the company's going?
I sleep pretty well at night, generally. One thing that I worried about before I came to NVIDIA, I've been privileged, starting from when I started work at Cray Research, working for Seymour Cray, father of supercomputing. I've been privileged to work with really smart people, really smart creative teams through my entire career, with a couple of exceptions I won't talk about. And so before coming to NVIDIA, that was something that I was a little bit worried about, but I'm so pleased and excited. We have just an amazing team, and it's a lot of fun to work with really smart and creative people. So if I'm staying awake at night, it's really because I'm too excited to sleep.
Okay. Well, thanks for sharing that with us today. Good
Sure.
job. All right.
It's good to see you again,
You
Rich.
bet. You bet.